Lesson 7.4 is on scientific notation. In this video, you will learn to express numbers in scientific notation, as well as find products and quotients of numbers expressed in scientific notation. And the vocabulary is scientific notation. Okay, so if we want to go from standard form, so standard form is just the normal way of writing a number, to scientific notation, these are the 4 steps that we want to follow. Step 1, move the decimal point until it is to the right of the first non-zero digit. The result is a real number A. Step 2, note the number places n and the direction that you move the decimal place. If the decimal is moved left, write the number as A times 10 to the n. If the decimal point is moved right, write the number as A times 10 to the negative n. And then remove any unnecessary zeros. So what does this look like? So I want to put the decimal place one spot after the first non-zero. So looking at my first non-zero is this 4. So I want right after it. So that would make my number 4.062. And then I don't need to put any of those zeros because after a decimal point, the zeros, unless there's another non-zero after it, they don't mean anything. So I'm going to leave that like that. And then I'm going to write it as times 10. And I want to know how many places I had to move the decimal place. There's a decimal place implied right there, right? So in order to get it from there to here, I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So that means this is going to be the number 12. Now, I like to think of this, you can remember right, left. You moved it to the left so that it's going to be positive. If you move it to the right, it's negative. You could do that. Remember that. Or what you could do is I'm thinking about this. I want these two things to be equal, this and what I changed it to. So this is a big number. This part right here, this just 0.062, that's a small number. So in order to make up for it, to make it multiply by a big number. So to a positive exponent is a big number. So in order to make it the same, I want to make it positive 12. If it was negative 12, that would be making the small number even smaller, which is not going to be close to this number in the trillions or whatever comes after trillion. Okay? So this one, the first non-zero number as I'm moving from left to right. So my first non-zero number is this 8. So that means I want the decimal. So now my number is 8.23. Okay, and then I'm doing my times 10. And I need to know what my n is. So going from here to here, how many places did it move? 1, 2, 3, 4, 5, 6, 7. It moved 7. Now, this is a really small number than what we started with. And then it got a lot bigger. It got to be 8. Before it was way less than 0. Now it's 8. So that means I want this to be a negative number. Or if you're remembering left and right, I moved my decimal place to the right, so I get a negative exponent on my scientific notation. Okay? You guys try this one on your own. And this one. Okay, if we want to have something in scientific notation and we want to go back to standard form, step 1, what we're going to do, if in A times 10 to the n, look to see if n is greater than 0 or less than 0. If n is greater than 0, you're going to move the decimal place n places to the right. If n is less than 0, you're going to move n decimal, or negative n places left. Okay? And then step 3, insert zeros, decimal point, and commas as needed for place value. So again, I like to think about this rather than memorizing things. You guys can totally memorize if you would like to. But I like to think about this. I'm multiplying by a big number. That means this thing is going to get bigger. If I'm making that bigger, which way would moving the decimal place make it bigger? This way or this way? This way, right? That's going to make it a bigger number if I move the decimal place that way. So I'm going to take 6.49, and I want to move the decimal place 5 times because it's the power of 5. So coming from here, 1, 2, 3, 4, 5. And now that's where my decimal place goes. And I want to fill in any of these loops with a 0. So I had 3 loops to fill in. So now my number is 649,000. And I'm just going to put in my comma to show that it's 649,000. Okay. This time, that's a small number because it's to a negative exponent, which means it's going to be like the same thing as 1 over 10 to the third, which is 1 over 1,000. So if you're multiplying by a really small fraction, it's like dividing by that. So this is going to get even smaller. So in order to make this smaller, I'm going to move my decimal place that way, or to the left if you're memorizing left and right for negatives or positives. Okay, so negative is left, positive is right, going to standard form. So if I have 1.8, I want to move my decimal place 3 times. So 1, 2, 3. My decimal place is now here, and again, I want to fill in any of the loops with a 0. So now my number is 0.0018. And that's it. Okay, try it yourself. Okay, if we're multiplying scientific notation, what we want to do is multiply like things together. So I want to multiply, where's my mouse? Okay, I want to multiply 5 and 2.3. So if I were to do 5 times 2.3, I would get 11.5. So I get 11.5, and then I want to multiply my powers of 10 together. So 10 to the negative 6 and 10 to the 12. So these are the same base. So when we have the same base, both of these have a base of 10, we add the exponents. So negative 6 plus 12, that's going to be times 10 to the positive 6. Now, this looks like it's almost like scientific notation, but it's not, because our decimal place is not right. So I want to have my decimal place technically right there. So to get it there, I move it once. So that's going to be 1.15. I moved it once to the left, or I made my number smaller, so I want to multiply it by a bigger number to keep it equal. 10 to the first. And then I have still times 10 to the 6. So all I did is I wrote 11.5 as 1.15 times 10, which is 11.5, right? Now I can combine those together. So I'm going to end up getting in the end 1.15 times 10 to the 7th, adding exponents because I'm multiplying with the same base. Now I'm in scientific notation. Okay, if I were to write this in standard form, so it says scientific notation and standard form in the directions, I'm going to take this number and I want to make it bigger. This part here makes it bigger, so I move my decimal place. So now I remove this 1, 2, 3, 4, 5, 6, 7. It's going to become filling 1, 1, 5. And then I have 1, 2, 3, 4, 5 zeros left to fill in. And then I'm just putting in my commas. And this is my standard form. And then this one up here was my scientific notation. Okay. You guys try that. If I'm dividing, it's the same concept. Again, we want to keep things. So I want to do my numbers together. So I'm going to divide 4.5 by 1.5. So if I do 4.5 divided by 1.5, I get 3. Okay, and I want power. If I do 10 to the 8th divided by 10 to the 2nd, remember when you're dividing with exponents with the same base, so the same base of 10, you subtract the exponent. So it's going to be times 10 to the 8 minus 10, which is negative 2. And this is in scientific notation, right? There's only one number to non-zero to the left of it. So this is okay. This is scientific. And then I want to get it into notation. I got this. Okay, and then we want to get it into standard form. So standard form gets rid of this times 10 to the negative 2. So this is making it smaller because of that negative. So in order to make this smaller, my decimal is going to move twice that way. Or if you think negative, it moves to the left. So 0 times 0.3, and then this is standard form. Okay, you guys try it. Okay, so we want to just be able to recognize it in word problems and stuff like that. So last year, Fuyus state registered over 4,000 watercraft. So if we were to write, 400,000. So that's 400,000 like that. Boat sales in her state generated more than 15.4 million. So 15.4 million, that's 15,400,000, like that. So we want to express the number of watercraft registered in the state and tax generated in state in standard notation. Standard notation or scientific form? Okay, standard. So we just did that. We wrote both of them. Okay, the next part wants each of them in scientific notation. So remember before we had 400,000. So if we were to write that in scientific notation, the first number coming left from right that not a 0 is that 4. So we want the decimal place to be right after that. So in order to get our decimal place from there to there, we're going to move it 1, 2, 3, 4, 5 times. So this is going to be 4 times 10 to the 5th, right? We made this smaller, so we want a bigger number to make up for it. Or if you want to remember, we moved our decimal place to the left, so it's positive. Okay, and then we want to do the 15.4 million, which was this number in standard form. So if I want that to be the first number that's not a 0 is that 1. So I want the decimal place to be right after that. The decimal place to be in there. In order to get it there from here, I move it 1, 2, 3, 4, 5, 6, 7 times. So this is going to be 1.54. I don't need those zeros anymore because after a decimal, the zeros don't matter, times 10 to the 7th. Okay. Next part, it says how many watercraft have been registered in his state if 12 times the number registered last year have been registered in all. Write your answer in scientific notation and standard form. Okay, so they said that there was 4,000 that were registered last year, and 4,000 in scientific notation was 4 times 10 to the 5th. So we're going to start with that number, 4 times 10 to the 5th. And they said it was 12 times that number. So I'm going to take that number, and I want to multiply it by 12. So I can do 4 times the 12, and 4 times 12 is 48. So I have 48 times 10 to the 5th. This is not scientific notation because I would want my decimal place to be there, but it's not. So in order to get my decimal place from after the 8 to before the 8, right there, I move it once. So that becomes 4.8 times 10, and I made it smaller. So I want to make up for it by multiplying by a number that's bigger. And then I still have. So the last thing I want to do is just combine those 10s. So 10 to the first and 10 to the fifth. That makes this number 4.8 times 10 to the sixth altogether. So that's the scientific notation. And in the standard form, I want to move this decimal place 6 places that way because I want to make it bigger because this is a bigger number. So multiplying by a big number makes the number bigger. So 4.8, if I move it once, there's 5 left. So I'm going to have 48 followed by 5 zeros. And then fill in my commas every 3 spaces, and that's it, 4,800,000, and that's it. Okay? You guys try these, and then you're done.